Okay, so look at this. Today we are going to learn a new thing. It's called algebra. So this is intro to algebra. Okay, now first thing is, what is algebra? So actually algebra is just like the language that describe rule or relationship in mathematics. Yeah, so let me give you an example. For example, if we have some numbers in here and then I'll put them in the table. So we have now, for example, this is number 2, this is number 4, now this is 3, and then 6, now this is 4, and then 8, and then this is 5, yeah, 10. Now if I write down the next one, for example, 6, what is this number in the right hand side of the table?
It's gonna be 12.
12, very good. Okay, now what if I put like this? For example, this is 7. What is the number here?
14.
Good. Now if I jump a bit here, what if I give you this number here? For example, this is 18.
9.
9. Now how about if this is 100?
50.
So in this case, you start to see the rule or the relation between these two numbers in the left side and right side. So basically you double it. Yeah? Very good. How about this one? If I have another table here, okay. So what if I have like this? This is 10, and then this is 5. Look at this here. This is 15, and then this is 10. Now this is 20, and then this is 15, and then the 25. This is 20. Now this is 30, and this is 25.
I know what the pattern
35,
is.
and what's
30.
This? 30. Now you start to see the pattern now. Yeah. For example, if this is now 60.
55.
55. So between this number, actually this one is this number minus 5, right? So what if I have, for example, here 100?
That's gonna be 105.
Very good. So this is like we're trying to find the rule that connects these two numbers, yeah, which is something easy. Okay. So this is just simple example actually to give you an idea about algebra. Let's look at the first table again. Eh? So you still remember the rule between these two numbers?
Yeah, double it.
You double it. Okay. So for example, yeah, what if this number is 1?
This number is gonna be 2.
2. Now what happened is actually we will have something more general, yeah. So remember when you got this number 4, yeah, it was this comes from this number 2, and then you multiply by 2. This 6, it is from 3 times 2. This 8,
equals
it
to
is
4 times 2.
4 times 2. Very good, and so on. Yeah.
5 times 2, 6 times 2,
Ah,
7 times 2, 9
very
times
good.
2, 50 times 2, 1 times 2.
Okay, so look at this now. When you have now something, let's say, we call it now as letter, yeah, instead of using number, I'm using a letter. So let's call it A. So if your left side number here is A, what is this number? Okay, you can call it B. Now, do you know the relation now between A and B here?
You double.
You double. So if you look at the previous examples, yeah, for example, these two, yeah, it is 1 times 2. This 100, it is 50 times
A
2.
times B.
And look at this again. This is now 9 times 2. So if I look at now this number, this letter B, what is this B equal?
The double of A.
The double of A. Well done. So B equals to A times 2. So if you look at now that rule, yeah, B is A times 2. This is actually giving us more general relationship in this table.
Yeah.
Because you can put any value of A and that will give you the value of B. For example, if you put the value of A equal to, say, 20, then what happens is
B is 40.
B is 40. If you put A equal to, say, 30,
B is 60.
if you put, say, the value of A equal to 100,
B is 200.
B is 200. If the value of A is 10,000,
B is 20,000.
20,000. So in this case, we have now a general rule that connects or relate, you know, between these two numbers A and B. Or I can write down something like this. For example, now instead of writing as A, I want to write with different letter. Yeah, for example, I'm using X instead of A. And this B, I call it now Y. So now if you look at from the previous relation here.
Times 2.
Okay, so what is here Y?
Y is equal to X times 2.
X times 2. Yeah. So this is also the same thing actually. Y equal to X times 2. So basically, this gives us like you know, the relation between these two values, yeah, between X and Y. Yeah. In mathematics, yeah, in mathematics, these letters, yeah, A, B, X, and Y, yeah, you can call them unknown, but generally we call them as variable. So we have the name for them, you know, variable, yeah, the name is X, Y, or any letter you want, okay? Okay, good. Now, let's look at the second table here, yeah? So you still remember, if I have 10 gives you 5, 15 gives you 10, and then 20 gives you 15, 25 gives you 20, 30 gives you 25, 35 gives you 30, and so on. So if I have now another letter, for example, here I put S, X, and here I put Y. Can you tell me now the rule that connects X and Y?
Y is equal to X minus 5.
Yeah, something like that. So that's very good. And you see now we have something different, yeah, compared to the previous one. Look, previously we have Y equal to X times 2, but now X minus 5. So of course there are like million, infinite relation that you can have in mathematics. You can have multiplication, you can have, addition or subtraction. Yes. So this is just simple example about the algebra. So it's a language that connects, that describe the rule or relation in mathematics, yeah, especially between, some variables, yeah, for example, x and y, like this one. Okay. Now, I want you to have a bit of play. So okay. If I give you, for example, so if I give you a table, yeah. Now I want you to find the rule that connects these numbers. Okay. So, for example, if I give you something like this. Now, can you find this number?
107.
So how did you find that number?
I realized 8 minus 1 equals 7, and 29 minus 22 is 7, so it must be plus 7. Then just added 7 onto 100.
Okay, so you already found the simple rule between these two numbers. So basically, this at 7 give you this number. This you add 7 give you 29. So that means 100 at 7 give you 107. Yeah. Or if I have, for example, here I call it x, and here I call it y. So what is y here? Equal.
Y is equal to x plus 7.
Nice. So these are just an example, yeah, of the simple relation between these two. One more, okay. Now, what about this one? Okay, this one, careful, it's a bit challenging. Yeah. So I have 4, 20, okay, and then 6, 30, and then 7, 35. Now, if I have 50 here,
10. This number is 10. Wait, what?
We found it.
Oh!
We found it. Goodness gracious. Okay, this
Ming, come.
Okay, let's open it.
Hi.
No.
Okay, look, we're almost done.
Yeah, we did.
So that's correct. Very good. It's 10. So how did you get this number?
4 times 5 equals 20, 6 times 5 equals 30, 7 times 5 equals 35. So the rule is times by 5. So but I didn't know what this was. So I divided 50 by 5, which made 10.
Okay. So if I have, for example, this is x and y, yeah. Now, can you write down what y is in terms of x?
Y equals to x times by 5.
Supposed to be opening it at your birthday.
Times
Your
5.
birthday is next week.
Now, normally when you are writing this variable x, yeah,
Ow, sakit.
and then you wanna do multiplication, okay? You wanna do multiplication. Sometimes when you already have this letter x and then you wanna do multiplication, instead of doing like this x and then times 5, yeah. Actually, this can be quite confusing. sometimes when you already have x as a letter, as a variable, instead of writing this multiplication using x, you can do like using small dot.
X dot 5.
So dot means the same thing, you multiply.
Okay.
Yeah. Okay. Now, actually, you can think of the relation between this x and y like this. So
I know how to set it up, Mom. Just wait it up.
yeah, you know what you put in, we call it this in and then out. Yeah. So this is like, you know, when you say what you put in, yeah, using x, the value that you get out is y. Okay.
X is in, Y is out.
Yeah. Now, if I have, for example, the rule is like this. The rule is like this. Y equal to for example, 2 times x and then plus 1. So this is the rule here. Yeah. Y is 2x plus 1. Okay. Now, if I give you the value of x here, for example, let's start with the simple one, the easy one. If I put the in value is 1, yeah, what is the out value, the y value that you will get from you know, this rule?
3.
So how did you get the number?
Because times by 2, it's 2, and then add 1.
Okay, very good. Now, what about if I have now this in, yeah, it is 4.
9.
Yes, very good. Now, if I have, say, 10.
It's 21.
21. Now, look, be careful with this one, yes? I have now this y, it's 33. The question is, what is the x value that can give you this y value equal to using the rule y equal to times x plus 1?
$16.
Very good, very good. Actually, you know. Now, let's do one more time. What if the y value is 101?
50.
50.
Sure.
Let's do one more time, yes?
Yeah, okay.
Okay, so this is your in or the x value, and this is the out or the y value, yeah? Right. Now, yes. Later, I'll open.
I'll open it up.
Okay. Look here, hey. If I give you this rule, yeah, y is x divided by 2. Okay, x divided by 2, and then you add 4. Yeah.
Yeah.
Okay, x divided by 2, and then plus 4. Now, if I give you, let's start from the simple one, do we? If x equal to, for example, 2,
X
what is the y value?
5.
So how did you get the number?
I divided it by 2, which is 1, and then added 4.
Very good. Now, how about if the x value is 6?
The x value is 7.
Okay, so basically 6 divided by 2, and then you add 4, yeah?
Yeah.
Okay, now this is a bit challenging, yeah? Careful. So if I have now the y value here, it's 20. Okay, so no, careful.
14. Wait, no. 10. Wait,
No.
no.
Think about this carefully. So if the y value here, it's
14.
No, actually you can calculate using a scrap paper. You can use paper to calculate the number. If you yes, so
Open it.
32.
yes, very good. So
Yeah.
normally when you go the reverse, reverse calculation, it's a bit challenging. I know. 32. One more, yeah.
Yeah. Okay.
So if I give you, for example, 50.
50. Okay.
You can use paper. No, you can use paper. Yeah, especially with bigger number, it becomes more and more challenging.
102.
No, but it's almost correct. Try calculate using paper.
92.
Yes, 92. Well done. So, you know, this is not something that I want to tell you. Yeah, in mathematics, you have 4 operations. Yeah, you have
Times, divide, add, subtract.
Add and subtract. Yeah, you know, normally. Oh, let me put like this. So you have times, you have divide, and then you have plus, you have minus. Yeah. These 2 operations
are like the ones that make bigger numbers. So for example, if this one had 2 and 4, it would just be 6. But if this one had...
No, actually what I want to say is, when you look at this operation that we have in mathematics, you have multiplication, you have division, you have addition, you have subtraction.
Repeated addition.
Wait, let me finish. The multiplication and division, they are actually at the same level, yeah, multiplication and division, and now this addition and subtraction, they are also at the same level, but you know, this multiplication and the division, they are actually higher compared to the addition and subtraction. Yeah, so this is actually very important. You see, when I have something like this rule, look at this again. Y equal to x divided by 2 plus 4. In this example, I put this bracket. Yes, I put this bracket.
Do it first.
Yeah, but you know what? Actually, even though you don't see that bracket, yeah, even though it's just written like this, okay, the first thing that you need to do is this operation, x divided by 2, okay, and then plus 4, even though there is no bracket here. because
These two go before these
because again the division, multiplication and division, they are higher
two. Yeah.
than the addition or subtraction. Now, you know, when you look at now, yeah, this rule, when you look at so for example, look at this now. I will write down slightly different, yeah. So if I have y equal to x divided by 2 and then plus 4. Now, what happened is in the previous example, we don't have bracket, okay? But you know that the division we will do first, yeah, x divided by 2. That's the basic rule. Now, look, if I have something like this now, I put the bracket here. That
plus 4.
Yes.
And then you divide y.
So divide x by them. So basically, this tells you something different. This tells you something different because in this case, what you do, even though there is a division here,
this divided by that.
Yeah. So you add this first because there is a bracket.
6. Like 6.
Okay. So you see now this rule becomes y equal to x divided by 6. And that gives you something different because now when you have, you know, this in and this out again, yeah. For example, the value of x now, I give you, for example, 6. So what is the y value?
1.
1. If I give you the x value now equal to 12.
2.
So you see now the different numbers here because I put the bracket in the different location. Okay, so that's actually quite
different.
You know, important.
But it's quite specific
important
because you
rule.
need a multiple of 6.
Yes. So I think you can imagine, yeah, you can imagine that the rule that you have it too. This is like you have a machine. Look at this. You have a machine. So this is the calculator. Yeah. And then whatever you put in there, you call it as x. And what comes out from that machine is the y. Okay. So now we will try to do some practice here from this book. Okay. Basically, you just fill up some number in the table. Okay.
Okay.
Yeah.
I'm gonna write in the book.
Yeah. Okay. Let me just stop now.